Hello, my name is Donald O'Hare, and this is my presentation for Physics 2, Lab 1. So in this lab, we use the quick separation of two pieces of tape to induce excess negative charge in the top piece, and then repeated that. So we had two negatively charged pieces, and we look to measure the amount of charge on each piece via their separation distance under gravity. And then we modeled that phenomenon in GlowScript. So for our initial conditions, we had all of the pieces of tape were 15 centimeters or 0.15 meters long. And then based on this and some data we were given in the lab, their mass was 0.00015 kilograms. And due to this, we know that the magnitude of the force of gravity to Earth on one piece would be 0.00147 newtons in the negative y, acting in the negative y direction. So in the experiment, as mentioned before, we charged the pieces of tape by ripping them off the bottom piece of tape quickly, and then brought that bottom piece back to neutral charge by rubbing it with our hands. And then we suspended one of the pieces and then held the other negatively charged piece directly beneath that. And we measured that the top tape raised 1.2 centimeters or 0.012 meters before becoming stationary. And since the tape stopped moving at that point, we know that it entered static equilibrium, in which the net forces acting on it sum to zero. And since the only two significant forces for this experiment were gravity and electric charge acting in the opposite direction, as since they were the same charge, the electric force acted in the positive y and gravity, of course, acted in the negative y direction. We know that they have fully equal magnitudes. As we said before, their magnitudes are both equal to 0.00147 newtons. So then solving backwards for Q in the electric charge equation, and it is important to note that we just kind of had to assume that both of the charges were equal for both pieces of tape, and there's really no way to like not prove this for this experiment, and it's probably not true, but we just had to assume that. And so we solved backwards using the magnitude and then distance of 0.012 meters, and we got a magnitude Q of 4.85 times 10 to the negative 9 coulombs. And we know that it is a negative charge, so we can conclude that the charge for both of those pieces was negative 4.85 times 10 to the negative 9 coulombs. So we modeled that same thing in GlowScript using the exact same initial conditions as our hand calculations, and we ended up getting the same result, while of course having to tell GlowScript to make it negative because of the nature of the electric charge equation, having q squared in there, since we're assuming they're both the same, that squared is going to wipe out any negative or positive charge. And so, which explains why the same charges repel, but in this case, you just kind of have to know that it's negative, which we were given in the lab itself. And then that's a GlowScript model of the forces acting on it. So some possible sources of error for our experiment are that we treated the tape pieces as point charges, although there was a charge evenly spread out across their entire area. And we assumed that each piece had the same exact charge. I spoke about this earlier. And we did ignore any dissipative forces like air resistance and friction that would have an effect, along with any charge that we lost when we were handling that tape, which of course also happened, but we just ignored. So to conclude, what if electrons had positive charge and protons had negative charge? There would be no difference because charges of the same sign repel whether they are negative or positive. And so in this case, if they were positive, they would repel the same amount with the same charge since they would have the same sign. And so that would have no effect if everything else remained the same. And why is it important to handle the charged tapes as little as possible? Because when you handle the tape, your hand is conductive enough to siphon off some of that charge into your body as it tries to return to a neutral state. And this would damage the experiment by messing with the amount of charge in the tape, which would give you ultimately inaccurate measurements. But for this case, it wasn't big enough to make a huge difference because we tried to minimize that. Thank you.